On page 433, exercise 8 says find the integral from -1 to 1 of the absolute value of 3x minus 2 dx. All this symbolism means find the area between the graph of y equals this integrand and the x-axis. Find the area between the graph of y equals the integrand and the x-axis from x equals the number down here, -1, to x equals the number up here. This calculus problem is really a geometry problem. If we make a table of values, in the x column we're using numbers that start at -1 and go up to +1. Plug these numbers into the absolute value of 3x minus 2. 3 times -1 minus 2 is -5, but y equals the absolute value of that. Absolute value of -5 is 5. Replace x with 0. Y equals 2. Replace x with 1. And y equals 1. So if we plot these points, the point -1, 5, the point 0, 2, and the point 1, 1, we get this graph because the point -1, 5 is right here. This is -1. This is 5. The point 0, 2 is here. And the last point here was 1, 1, which is here. Of course, the graph has lots of other points. So we just plotted these. By the way, when x is some number, I'm not sure of what that number is, y is 0, so we'll find that. When x is some number, I'm not positive what it is yet, that's when y is 0. This equation is true when x is 2/3. So x equals 2/3 is an important number because that's this number right here. To find the integral of the function that's graphed here in blue, the absolute value of 3x minus 2, from -1 to 1, means find the area between this blue curve and the x-axis from x equals -1 to x equals +1. We want the area between the curve and the x-axis. So that region we're talking about is just two right triangles, a large one and a small one. The area of a triangle is 1/2 the base times the height. So that first triangle has a base of however far it is between -1 and the number 2/3. The distance from this number -1 to this number 2/3 is 1 2/3, which is the same as 5/3. That number is the base of this triangle here. And the height of that triangle is 5. The height of the triangle is 5. So right here is the area of that green triangle. I'll make the triangle next to it red. This little tiny triangle here. The area of that triangle is 1/2 the base times the height. The base is however far it is from the number 2/3 to the number 1. The distance between 2/3 and 1, or 2/3 and 3/3, is 1/3. 1/3 is the base of this little triangle. And the height of that triangle is 1. This is 1 unit. The area of a triangle is 1/2 base times height. For this red triangle, it's 1/2 times 1/3 times 1. So all this in red right here is the area of that little red triangle. If we add these together, the area of the green triangle plus the area of the red triangle, we get the value of this integral. The area of the green triangle is 25/6. 1 times 5 times 5 over 2 times 3 times 1. The area of the red triangle is 1/6. 1 times 1 times 1 over 2 times 3. When we add 25/6 plus 1/6, we get 26/6, which can be reduced to 13/3. That's the value of this integral up here. Oops. Value of this integral. It's called a definite integral. Is 13/3. On page 434, exercise 36 says find the area between y equals 2x squared minus x minus 3 and y equals x squared plus x. The question is to find the area between these curves. So you would take your time to graph this parabola and then also graph this parabola. It'll take a while and you'll end up with this picture right here. So we have these two parabolas. You do have to find the intersection points, and we find those algebraically by setting the first trinomial to, which I believe is drawn in blue here, to x squared minus x minus 3. Set that equal to the red one, the second one, which is red x squared plus x. We set these equal, that's how we find the intersection points. If we subtract x squared from both sides and subtract x from both sides, this right side here will be 0. Then x squared minus 2x minus 3 can be factored. It's x minus 3 times x plus 1, which equals 0 when x is equal to 3, or when x is equal to -1. And when x is -3, get the y by plugging -3 in the blue or in the red, either one. If you plug 3 into the red, 3 squared plus 3 is 12. You'd get the same thing if you plug 3 into this blue. Plug -1 into either. -1 squared plus 1 is -1 squared plus -1 is 0. You'd get 0 if you plug -1 into the blue also. So 312 is an intersection point, and -1, 0 is an intersection point. 312 and -1, 0. So that's how we found this point 312 and this point -1, 0. To find the area between these, after they're graphed, we have to take whichever graph is higher, that would be the red one, x squared plus x, minus whichever graph is lower. In this case, the blue one is lower on this page than the red. And the blue is, in parentheses, 2x squared minus x minus 3. So we take whichever graph is higher minus whichever one is lower. Dx gets attached to the end of all this. And then we integrate. We write an integral symbol, which with numbers attached to this, which will be in the region we're looking for. We're looking for the area between the red and the green, which I'll color it in here. We're looking for the area of this region. So we take the higher minus the lower, that's the red minus the blue, and we attach to the integral symbol the smallest x and largest x in the region. In this region, there's no x smaller than -1. That goes here. And in this region I'm coloring in, there's no x bigger than 3. So the y's, the 12 and the 0, we don't really need those. So smallest x in the shaded region down here, biggest x in the shaded region up here, and the integrand is the graph that's higher on your page minus the graph that's lower. And now we'll just do the calculus here. We write the integral of x squared plus x minus 2x squared plus x plus 3 dx from -1 to 3. So to get from here to here, I distributed this negative sign. And write the integral from -1 to 3 of -x squared plus 2x plus 3 dx. To get from here to here, I combined like terms. X squared minus 2x squared is -1x squared. X plus x is 2x. And I brought down the plus 3. We now have 3 terms. So in the next step, I'm going to write 3 separate integrals. The integral of -x squared dx plus the integral of 2x dx plus the integral of 3 dx. So same 3 terms, -x squared is right here, plus 2x is right here, and plus 3 is right here. Each of the terms gets its own dx. And any constant that's multiplied gets written to the left of the integral sign. In the first term, it's the -1 to the left of the integral sign. In the second term, it's the 2. And in the third term, it's the 3. Those are to the left of the integral symbol. Then I bring down the -1. The integral of x to the second dx is x to the third over 3. The plus and the 2 get copied. The integral of x to the first dx is x to the 2 over 2. Copy the plus, copy the 3. And the integral of dx is just x. Instead of writing plus c, make this bracket with the 3 and the -1 attached. So we have this, negative x cubed over 3 plus x squared, because these 2's cancel, plus 3x. The bracket notation says replace every x with 3, then make a subtraction symbol, then replace every x with negative 1. So we have this bracket here, means we write negative 3 to the third over 3 plus 3 squared plus 3 times 3, then minus parentheses negative 1 to the third over 3 plus negative 1 squared plus 3 times negative 1. So right here, all the x's are replaced with this number. And after the subtraction, all the x's are replaced with this number, the negative 1. Now it's just arithmetic. That's negative 27 divided by 3, which is 9. 3 squared is 9. That's also 9. Over here, we make sure we do the exponent first and then multiply by this negative 1. Negative 1 cubed is negative 1 times this negative makes that positive 1 third. Here we're squaring negative 1. That's positive 1. Here we're multiplying 3 times negative 1. That's negative 3. All that is 9. This minus can distribute. We have to distribute it. It's minus 1/3, minus 1, and minus a minus, so that's plus 3. 9 plus 3 is 12. 12 minus 1 is 11. 11 minus a third is 10 2/3. And we're done. That number, 10 2/3, is the area of this region that's shaded in green. 10 2/3 square units are inside here. So calculus is used to find areas of odd shapes. It also can be used to find the average value of a function. So here's a formula. The average value of a function let's call the function f of x over an interval, let's say from a to b, some number to some number, is f with a bar over it is the symbol for the average value of f. It's going to be 1 over b minus a, those are the endpoints of the interval, times the integral from a to b, a and b are the endpoints of the interval, of the function dx. This formula is the formula to find the average value of a function over a given interval. So I'll do one example, because they're all the same pretty much. It's page 434, exercise 42. Y, which could be called f of x, does not say that in the book, but it's the same thing, equals x squared minus x plus 1. And the interval is from 0 to 2. The directions are to find the average value of this function over the interval from 0 to 2. The average value of any function is 1 over b minus a times the integral of the function from a to b. So for this exercise, it's 1 over 2 minus 0, because this number is a and this number is b. So it's next to that is the integral from 0 to 2. 0 and 2 are a and b. The integral of x squared minus x plus 1 dx. This number out here is a half, so we can write 1/2 the integral of x squared dx minus 1/2 the integral of x dx plus 1/2 the integral of dx. So from here to here, we're distributing the integral. There's one, there's one, there's one. We're distributing the dx, 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 dx. Also, this 1/2. This 1/2 is times each of these terms. There it is, there it is, and there it is. This equals 1/2 x to the third over 3. Copy this minus, copy this 1/2. The integral of x to the first is x to the second over 2. Copy this plus, copy this 1/2, and the integral of dx is just x. Integrating from 0 to 2. So we'll put this bracket. That's x to the third over 6, 2 times 3, minus x to the second over 4, 2 times 2, plus, I could leave that 1/2 x, or I could write it x over 2. This bracket tells me the next thing I do is everywhere there's x, I put 2. So I just replaced every x that I saw with a 2. Then minus, parentheses, every x now gets replaced with 0. 0 to the third over 6. Minus 0 squared over 4, plus 0 over 2. That's 8 right there. That's 8/6. 8/6, which I can write as 4/3. That's 4 over 4, which is 1. 2 over 2 is 1. And all this is 0. 4/3 minus 1 plus 1 minus 0 is 4/3, and that's the answer. That number is called the average value of this function. 4/3 is the average value of this function for all the x's between 0 and 2. Right, the next section is called integration by substitution. And integration by substitution is what I've always called it integration using magic chalk. Because when I started learning and teaching math, we did everything with chalk. So here's how it works. On page 443, exercise 4, it says find the integral or antiderivative of x to the third plus 1 to the fourth times x squared dx. So here's how we find the antiderivative using a method called substitution. Over this side, we let u equal something that is over here. How you know what to let u equal, we'll talk about that later. From u, we get the derivative of u with respect to x, which here would be 3x squared plus 0. So du equals 3x squared dx, because I multiplied both sides of this equation by dx to get that equation. So here's how integration by magic chalk works. We say, we wish this said exactly that. This says x squared dx. We wish it said 3x squared dx. In other words, we wish there was a 3 here. So you get a magic wand or a magic piece of chalk. You wave it over this 3 times. You say, I wish there was a 3. I wish there was a 3. I wish there was a 3. Abracadabra. There it is. I wish there was a 3 here because I wanted this to say the same thing this says. Now, it really is not magic. We say it is legal to multiply the given by 3 as long as we also multiply by the reciprocal of 3. Then we can say the original and all this down here are equal to each other. Since 1/3 times 3 is 1, we're multiplying by 1, so it's not changing the value. So here's what the next step looks like. The 1/3 that appeared with our magic pen gets brought down. This symbol gets brought down. This thing in the blue gets replaced with U because that equals U. All of this, oh, before I say that, this 4 exponent just gets brought down. All of this inside the green gets replaced with du because 3x squared is equal to du. So this is a problem everybody should be able to do. This right here, where we say bring down the 1/3. The integral of u to the 4th du is u to the 5th over 5 plus c. And here's the final answer. This is not it up here. It's 1 over 15, because 3 times 5 is 15. That u right there is really x cubed plus 1. Instead of u to the 5th, it's really x cubed plus 4 to the 5th. I mean x cubed plus 1. Sorry, I'm fixing it. I don't know where that 4 came from. All right, so there's the 1. 3 times 5 is 15. It says u to the 5th. U is really x cubed plus 1. So now if you check it, you'll see why this all makes sense. So this side is for checking. We just achieved the answer 1/15 times x cubed plus 1 to the 5th plus any constant. If that's the right answer, then the derivative of the answer will be the original integrand, which I'm showing you over here what that was. So let's see if it is. The derivative of a number times something to a number is this exponent times this number. 5 times 1/15 is 5/15. Ding. X cubed plus 1 gets copied. Ding. The 5 becomes a 4. Ding. And we multiply by the derivative of what is in the parentheses. The derivative of what's inside here is 3x squared plus 0. And the derivative of any constant is 0. Do you see 5/15 times 3? You know what 5/15 times 3 is? It would be 15/15, which is 1. That means we have 1 times x cubed plus 1 to the 4th times this x squared plus nothing. That's the original integrand. Here's another example. Number 10 on page 443. The integral of the natural log of x raised to the 7th times 1 over x dx. So what I said in the last one is let u equal something. Then get the derivative of u with respect to x. Hopefully you remember that the derivative of the natural log of x is 1 over x. Multiply both sides by dx, so du equals 1 over x dx, which is exact. So what I say next is I say I wish this were over here, and it is. I don't even need to put a number in there with magic chalk. So I'm just doing substitution now, copying the symbol what does the natural log of x equal? The answer is right here. That exponent gets copied. What does 1 over x dx equal? The answer is right here. So we have the integral of u to the 7th du, which is u to the 8th over 8, plus c. The final answer is not u to the 8th over 8 plus c, but it's the natural log of x to the 8th over 8 plus c. That's it. I'll let you do the check the way I did in the last problem. When you are going to check it, you should write the answer in this form. 1, understood here, 1/8 times something, the natural log of 8, x, natural log of x raised to the 8th. So when you check it, use the 4 bells to see that it checks. So here's the trick, is letting u equal the correct thing. So here are some rules. U has to equal something that's over here. Du, whatever du always comes from u. Whatever du is has to also be here. But a number can be missing. If a number is missing, you can make the number appear with your magic chalk. If a letter is missing, then you're going about it wrong. You're on the wrong track. But if du is here, except maybe missing a number, then you're good. And the third rule, this is the final rule, the original has to turn into an integral that you know. Like we know the integral of u to the 7th du. And we know, in this one, we know the integral of u to the 4th du. So the rules were, u has to equal something that's here, du has to also be here, except it's okay if a 3 is missing. And then it has to turn into something we know. We know the integral of u to the 4th du. So 3 rules. Let's show those with number 18 on page 443. The integral of t squared, e to the negative t cubed, dt. So if you've never done this before, it could take a while to make a decision for what to let u equal. So I've done this before. I'm going to let u equal this exponent, negative t cubed. The derivative of u with respect to t is negative 3t squared. So the derivative of du equals negative 3t squared times dt. If I change the order of what's given, the integral of e to the negative t cubed, put this t squared over here, dt always stays at the end. So switching the order is definitely okay to do. When I get here, I say, I wish it said negative 3t squared dt over here. And it almost does it, just the negative 3 is missing. So here's a magic chalk, a magic wand. I wish there was a negative 3 here. I wish there was a negative 3 here. I wish there was a negative 3 here. There it is. Abracadabra. Well, I really can make that number appear out of the blue as long as I put the reciprocal of that number also. Negative 3 times negative 1/3 is positive 1. That's why the original and all this down here are equal to each other. Now we copy the negative 1/3, copy the symbol, copy the e. What does this exponent equal? The answer to that is right here. What does all this in the green equal? The answer to that is right here. So I let u equal something that was here. du is also there. And this is an integral I know. I know the integral of e to the u du is e to the u plus any constant. So the final answer is negative 1/3 e to the u, but u is actually negative t cubed plus c. Just turn the u back into what u equals, and we're done. Number 20. The integral of 1 over 2 plus 8x dx. I'm going to let u equal 2 plus 8x. The derivative of u with respect to x is 0 plus 8. So du equals 8 times dx. So what I'm doing right now is I'm wishing there was an 8 here. There's 8 dx. I wish this said 8 dx. The 8's missing. Abracadabra. Well, if I put the 8, I also have to put in 1/8. Since 1/8 times 8 is 1. That equals 1/8. Bring that down. Integral 1 over. What does 2 plus 8x equal? The answer to that is right here. What does all this in the green box equal? The answer to that is right here. And this is an integral I know. I know the integral of 1 over u du is the natural log of u. That's an integral formula I know by heart. So the answer is 1/8 natural log of 2 plus 8x. That's really 2 plus 8x plus c. You're done. And I'm going to do just one more. Actually, I think that's it. The end.